right there. See the periodic table up there? Those are all the different elements. And a chemical reaction is like when the different elements go to a dance. And I'm going to show you a chemical reaction today. So this is one chemical. This is called potassium iodate. And this is like potassium, which is K. Can you find the K on the table? Up there? You see the K? It's like 4 down on the left. That's potassium. And iodine is I. Can you find the I? The I is at the bottom right. Somewhere around there. You see it? So in this bottle is potassium and iodine dancing together. All right? So they're dancing together, and I need 40 milliliters of this. So I'm going to use my graduated cylinder and measure it precisely to 40 milliliters. And I got a little too much in there, so now I'm going to use this. Does anyone know what this is called? A sucker. Who said it? It's called a pipette. Good job. This is called a pipette, and that's also on the board for your vocabulary for next week.
A pipette.
You use a pipette when you want to add a little liquid or take a little bit out.
Sounds French.
It is French, Kevin. Okay. Yes. You may record this if you like to show your parents. Well, no, not right now, though. Wait. We'll wait until it actually happens, and then you can. All right, so that's potassium and iodine. This is hydrogen peroxide. And this is like the H from the periodic table up there, and the O's. You see the O over there on the right? Hydrogen and oxygen dancing together in this bottle, right? And we're going to put 40 milliliters of them in here, in this graduated cylinder.
Why is it always clear?
Too many people talking again. All right, so this is potassium and iodide dancing together, and hydrogen and oxygen dancing together. So in every chemical reaction, you also have something called a catalyst. The catalyst is not a reactant or a product, but it shakes things up. And our catalyst in this chemical reaction is called malonic acid. And it has manganese, which is Mn. It's about in the middle, 4th row down. And also sulfur, which is S. And we need 40 milliliters of this, too. So I'm going to pour this in here. I still hear talking. Put a little too much in. Yeah, you guys, I'm not going to do this every Friday if you talk like this all the time. Okay, so there's 40 milliliters of these guys. So, those are all our actors. This is the dance. This is the gym. Okay? I would like what's your name? Jay Sean, come on up. I want you to add the potassium iodide into the beaker.
Do you want me to move?
Can you do that? Are you getting this right here?
Yeah.
Okay. Okay. Now, see if you can stir it up with the stirring rod. This is a stirring rod. It's made out of glass, so don't be too rough with it. Stir it up. Get it all mixed up. Again, this is potassium and iodide dancing together at the dance. Right? And tell us, Jay Sean, what do you see? Do you see anything happening? No. And that's right, there is nothing happening. It's still a very clear liquid. Thank you. You can sit down. Thank you. And potassium and iodine are dancing with each other there at the gym. Next, we add hydrogen peroxide, which is hydrogen and oxygen. Kevin, would you come up and add that to the beaker? And then Kevin, go ahead and add it.
Boom.
Good job. And then take the stirring rod, Kevin, and stir it up. And then,
Here comes the show, everybody.
let's see. Kevin, do you see anything happening?
No.
Still nothing happening. So, hydrogen peroxide and potassium iodide have gone to the dance, and they're dancing with each other. Potassium's dancing with iodine, and hydrogen's dancing with oxygen. And everything's fine. But now here comes the catalyst, and he's going to mess things up.
The party pooper.
He's going to make it so hydrogen dances with someone else, and potassium dances with someone else. And then they're going to leave the dance with different people than what they came in with. Yeah, so this is the part where if you want to film it, you should come up over here in an orderly manner. You can focus on this. This is not dangerous at all. It's not dangerous for you to be that close. If it were, I wouldn't let you. All right, are you ready? Are you ready? Okay, so one of the signs of a chemical reaction is that there's a color change. Tell me what color or colors you see here. Call them out.
Yellow.
Yellow.
Wait for it.
Blue.
Green. Not yet. Not here. Purple.
Purple maybe, yeah.
Purple.
Purple.
That's
Clear.
really green. That's
Yellow again.
Green.
Blue.
Oh, that's so cool.
Now watch this.
It's a dance.
If I pour it, so what's happening?
It's
Same
changing
colors.
They're changing partners.
Oh, that's
Now if I pour it into this, it still changes to blue at the same time. Let's put a little bit in there. Now even in separate containers they change at the same time. See that? Now I'm going to give you a little clue. There's starch in there, in the malonic acid. And when starch is dancing with iodine, it turns blue. So what's happening when the solution is blue? Starch is dancing with iodine. What happens when the solution goes clear? What's iodine doing then? Dancing with somebody else, isn't he? Yeah. He's a two-timer. Yeah. So that's what's going on here.
He's a player.
Iodine is changing dance partners, and that's what's causing the colors to change. That's what chemical reactions are like. We're going to learn a little more about those this year.
I can't wait for the next experiment.
And I thank my camera